Hello everyone. I want to introduce something about turbo code to you. This is my topic: analysis of exploration of the application of turbo code on wireless communication. First, I want to introduce some history about turbo code. In 1993, turbo codes were introduced by Barrow and his friends in their paper Near Channel Limit Error Correcting Coding and Decoding. Turbo codes published in the of IEE International Communication Conference. In a later paper, Barrow gave credit to the intrusion of G and P, who in the later 1980s highlighted the interest of probabilistic processing. He adds R had already imagined coding and decoding techniques whose general principles are closely related, although the necessary calculations were impractical at that time. Then the application turbo codes are used extensively in 3G and 4G mobile telephone standard, for example in HSPA, video and LTE, media FLO, terrestrial mobile television system from call communication. The interaction channel of satellite communication systems such as DVB-RCS and DVB-RCS2. New NASA missions such as Mars Reconnaissance Orbiter now using turbo code is an alternative to RS Viterbi codes. Turbo code used such as block turbo coding and convolution turbo coding are used in IEE 802.16, a wireless metropolitan network standard. There are many algorithms used in turbo code. The basic task of the decoder is based on a set of coding rules that is given estimation sequence closed sister C, similar mostly to information sequence C by the receiving and sending of sequence R. When C equals C plus, the decoder decodes correctly. There are two criteria of common decoding: maximum likelihood correction and maximum a posterior criteria. According to two different aligning, there are two different decoding algorithms derived. Solver algorithm and map algorithm. The introduction of map algorithm led the convolution of excellent performance. Can be used as two encoders of turbo codes while using the feedback decoding structure to achieve a soft input, soft output method, and simplifies the maximum likelihood translation of code algorithm and to achieve performance close to the channel capacity limit. The computation amount of solver algorithm is small and its purpose is very clear, that is to find the maximum likelihood pace. Comparison of its two pace, one is maximum likelihood pace and the other pace mustn't be the most competitive pace, but a pace whose judgment different from the maximum likelihood pace and coinciding with the maximum likelihood pace. The pace that is more competitive could be discarded in the decoding process. In iterative decoding process is not conductive to the subsequent decode bits, which is the reason why the decoding of solver is less than that of a map. Then I want to show my program to you in MATLAB, so we need to open the MATLAB. Firstly, we need to choose the main file in the code. Okay, and run it. Actually, you don't need to input any number in it, you just need to use the default value. And start. It's running because it needed to a little time to finish it, so I wanted to continue my speaking. Uh, Before the restart, I wanted to mention something. My code shows some tables of data in MATLAB, some figures in this PPT, and my report is drawn using the data from MATLAB in Excel. My code can't show you the figure in direct. This is the result from MATLAB. You can see the data of table, and after processing we can get some clear figure using Excel, and this is finished figure, and then I want to introduce something about it. In the first figure, with the increase of the number of iterations, the performance of turbocode is improved gradually. When in iteration of a large number, improvement is situated. In the simulation, the decoding time also increases linearly with the number of iterations increased. From 1 to 2 iteration, the performance of turbocode is significantly improved. This is because the two decoders share the same information. The decoder can get more information about the information input and make more accurate judgments. The speed of improvement of performance of turbocode slowed down with the number of iterations increased. This is because after multiple iterations, the decoder already have an outline of the input code word, and the information can't be updated. After several iterations, its performance will reach a limit. Generally, turbocode is saturated between 5 to 10 times iteration. And in the first and second figures, we can see the difference between the solver algorithm and the logarithmic algorithm. Generally, the logarithmic algorithm is much better than solver algorithm in some respects. We even can't see the outcome of 3 to 4 iterations of these figures using logarithmic algorithm. This is because it is reaching to a limit. And in the last two figures, it is obviously that the unpunctured turbocoding has better performance for communication. This fact is very interesting, but you should know that punctured coding requires large input complexity and expansion of bandwidth. Generally, the bandwidth efficiency of punctured turbocode is much better. Further research showed the EBNO is and in 3dB. The turbocodes operated in 1 to 5 iterations, except for the comparison with the convolutional coding and its weighted decoding. And the last one is conclusion. Since 1993, the advent of turbocode, the research for the theory and the application related to turbocodes is always a hot point in the field of information and coding theory. The appearance of the turbocode is one of the most exciting things of the sector of China coding in the last 20 years. It can fully combine interlevel and with convolutions code of recursive systematic together, and using the soft input, soft opcode method. The code scheme on the growth channel can reach performance of nearly Shannon limit. In the third general mobile communication system, the representative of the 3GPP3 standard China coding scheme WCDM HCDMA 2000 and TD-SCDMA using turbocodes for high speed and high quality communication service. Implementation of the standard of the third generation mobile communication provide important background. Before we end this lecture, we need to check the MATLAB. Now the MATLAB has been finished. Generally, we need to get the last table in the program because it is the most accurate. Thank you very much. Thank you for your listening my lecture. Thank you.